Imagine a creature so small you could lose it in the palm of your hand, making a decision, in a fraction of a second, to die for a colony it will never see grow old. That happens almost every single day, somewhere in the world, the moment a honeybee stings a mammal. The sting itself takes less than a second, the dying takes minutes, and by the time it's over, that bee has left behind something far more dangerous than its own death, a chemical signal that turns hundreds of its sisters into furious reinforcements, all converging on the exact same target. So why would evolution build a weapon that kills the one who uses it? And if that's true, why do some bees sting and simply fly away, completely unharmed? That contradiction has puzzled scientists, beekeepers, and curious explorers for centuries. And the answer, as you're about to find out, is stranger and far more brilliant than it first appears. I'm Nathan Wild, and after years spent crouched beside hives with my heart pounding in my throat, I can tell you this: nothing has tested my nerves quite like standing still in front of an agitated swarm, trying to understand the invisible line between a creature that tolerates you and one that's decided you're a threat. To understand why bees sting, we first have to understand what a sting actually is. It isn't a mouth, it isn't a bite. It's a modified egg-laying organ, an ovipositor, that somewhere in the depths of evolutionary time stopped laying eggs and started delivering venom instead. That single detail explains something most people never think about. Only female bees can sting. Every drone, every male bee in the hive is completely defenseless. He has no stinger at all. The entire art of stinging belongs exclusively to the daughters of the colony.
Now, here's where it gets personally fascinating to me. A honeybee's stinger isn't smooth. Under a microscope, it looks almost like a tiny harpoon lined with backward-facing barbs. Against the soft, elastic skin of a mammal, those barbs catch and lock in place. The bee tries to pull away, and instead of freeing the stinger, it tears its own abdomen apart. The stinger, the venom sac, even part of its digestive tract stay behind, still pumping venom into you long after the bee itself has died. Personally, I find that almost impossible to process the first time you really understand it. A creature engineering its own destruction mid-attack as a kind of biological insurance policy. Before we go further, I want to invite you to come along on these expeditions with me. Every week, I dive into a different hidden corner of the natural world. The small, the overlooked, the astonishing, and if that's the kind of curiosity that pulls at you too, this is exactly the place to stay close and keep exploring. Here's the twist scientists eventually uncovered, and it changes the entire story. That barbed, self-destructing stinger isn't really built for you. It's built for something with a much tougher hide. Against another insect's hard exoskeleton, the barbs don't catch the same way. A honeybee can sting another insect, a wasp, a hornet, even another bee, withdraw its stinger cleanly, and fly off completely fine, ready to sting again if it has to. That distinction matters more than it might seem. It tells us that the bee's most extreme weapon, the one that costs her everything, evolved in a world where the biggest threats weren't other insects at all. They were
Mammals with claws strong enough to tear open a tree trunk, thick fur to shrug off dozens of stings, and an appetite for honey, wax, and protein-rich larvae that no single sting could ever fully deter. Against an enemy like that, a bee needed something more permanent than pain. She needed a weapon that stayed behind after she was gone. That barbed weapon appears to have evolved as a defense against thick-skinned raiders. Bears, badgers, honey-hunting mammals, anything large enough and persistent enough to tear a hive apart for the honey and the brood inside. Against skin like that, a single bee's life is a small price to pay if it means the rest of the colony survives. Sacrificing one daughter to drive off a predator that could destroy tens of thousands of relatives, that's not a tragedy in evolutionary terms. That's a bargain. And it gets even more layered, because that final act of sacrifice isn't silent. As the stinger tears free, it releases an alarm pheromone, a scent that to other bees smells unmistakably like danger. Isopentyl acetate, if you want the chemical name for it, but to the hive it might as well be a siren. Within seconds, nearby guard bees pick it up and respond, not by retreating, but by moving straight toward whatever stung their sister. The more I learn about these animals, the more convinced I become that the colony behaves less like thousands of separate insects and more like a single organism with thousands of tiny expendable hands. One bee dying isn't really an individual death at all. It's closer to losing a fingernail to protect the whole body. But there's a fascinating exception hiding right at the heart of the colony, and it overturns almost everything we just learned.
The queen bee has a stinger too, but hers isn't barbed the way a worker's is. Hers is smooth, curved, built to be used again and again without ever costing her life. A newly emerged queen will use that stinger for one purpose only: to hunt down and kill rival queens before they can challenge her for the throne of the hive. She can sting repeatedly and walk away every single time. The most lethal stinger in the colony almost never touches a human at all. So when do bees not sting? This is where most people get it completely wrong. A honeybee foraging on a flower far from the hive has almost nothing to defend. Her entire focus is pollen and nectar, not territory. Step near her, even brush against her, and in most cases she'll simply move away. Stinging costs her everything, and unless she's grabbed, trapped, or directly threatened, that trade is never worth making. Most stings people experience happen by accident: a bare foot, a hand reaching where it shouldn't, a sleeve pressing a bee against skin with nowhere left to escape. I've walked through fields thick with foraging bees, close enough to hear the hum of every wing beat, and never been touched. It's only ever changed the moment one felt cornered. It's near the hive itself where the calculation flips entirely. That's the colony's nursery, its food stores, its entire future, all in one place, and guard bees treat any disturbance there with total seriousness. Vibration, certain colors, even strong smells like sweat or perfume can trigger a defensive response. Genetics matter too. Some lineages, like the so-called Africanized honeybees, respond to a perceived threat faster and with far greater numbers than gentler European strains, a difference researchers are still mapping out in real time. It's worth pointing out, too, that not every striped buzzing insect plays by these same rules. Bumblebees and most wasps carry a smooth stinger, without the barbs that doom a honeybee. A bumblebee can sting, pull free, and sting again, and again, with no self-destruction involved at all. It's one of the reasons a wasp encounter often feels so much more unpredictable than a honeybee one. There's no single sacrifice, no final act, just a weapon that's always ready to be used a second time. And here's something that even now doesn't have a fully settled answer. Why does the exact threshold for triggering that mass defensive response vary so much, not just between species, but between individual colonies of the very same species? Some hives erupt at the faintest disturbance. Others, just meters away, barely react at all. Researchers have proposed genetics, recent threats, even the personality, if you can call it that, of the queen herself. Honestly, nobody has the complete picture yet, and that uncertainty is part of what keeps pulling scientists back into the field year after year. What stays with me most after everything isn't the danger, it's the math behind the sacrifice. A creature with a brain barely the size of a grass seed, making what amounts to a calculated trade, its own life for the survival of tens of thousands of relatives it will never personally meet. That's not mindless aggression. That's something closer to devotion, written into the architecture of an insect's body by millions of years of evolution. If a single bee's death can hold that much purpose, imagine what's waiting in the colonies, the swarms, and the hidden corners we have.
Next time, we're stepping into the world of hornets, the bee's most feared rival, and a sting built for an entirely different kind of war. Stay close. The expedition isn't over yet.